Notice what repeats. Repeated steps reveal rules. Shortcuts hide in patterns.
Welcome to the forest floor. Down here in the brush, if you watch a colony of ants gathering food, you will see a lot of chaotic, overlapping trips as they search for the best way home. But eventually, they notice they are walking the exact same journey over and over. When that happens, they lay down a single scent trail, turning that repeated route into one highly efficient highway. Mathematics works the same way. When you find yourself repeating the same steps in a calculation, you do not have to keep doing it the long way. You can generalize it into a permanent shortcut. Looking for regularity simply means identifying exactly what is repeating and locking it into a rule so you never have to walk the long way twice. Let's track a specific ant on her daily trips to see how this works. We will count the exact number of seeds she manages to carry over time. This table shows our ant's progress. On trip number 1, our input, she has 5 seeds in total, our output. By trip 2, she has 9, trip 3 is 13, and trip 4 is 17. Notice what happens as we move down the rows. Every single time the input increases by 1, the total output increases by exactly 4. To build a rule, we cannot just look at that repeating addition of 4. We also have to account for where the ant started. On that very first trip, she already had 5 seeds. So we formulate our rule by combining those pieces. The output, y, equals our repeating addition of 4 times the input, x, plus a starting offset of 1 to make that first trip equal 5. Recognizing that simple additive repetition allows us to construct a linear shortcut that works for any number of trips she takes. Watch this branching scenario where an ant recruits foragers. 2 ants, then 4, 8, 16, 32. Instead of adding, every step multiplies the previous term by 2. We can express this repeated multiplication compactly using exponents, or powers of 2. When your regularity involves multiplying by the same factor over and over, the shortcut becomes an exponential formula rather than a linear one. We can also find these shortcuts in geometry. Watch this ant as she climbs a steady incline up a moss-covered twig. This plane maps her exact path at points 1, 3, 2, 5, and 3, 7. Analyzing this movement, for every forward step of 1 on the x-axis, the ant takes an upward step of 2 on the y-axis. Look at that repeating rise and run. What linear rule captures this pattern? Because this repeats, the slope stays constant. We lock that in as the rule, y equals 2x plus 1. A consistent, repeating geometric change translates directly into a reliable algebraic equation. Here is a tool you can use for any new sequence. Just ask yourself, each time I am doing what? Pinpointing exactly how those values change, whether through adding, multiplying, or rising, lets you construct a formula that covers every step of the sequence. So the next time you face a string of calculations, look closer. What repeats in these steps?
Spot the repetition. Turn it into a rule. Reason once, use often.